Alrighty. I'd like to take some time to discuss our command and data handling system because these interfaces are going to be very important for our satellite design. Let's start off with some requirements. I want to pay special attention to CDH number 1, which states the CNDH system shall process ephemeris data. Now, as mentioned earlier, our ephemeris data requires us to take images of the moon and then process those images to determine our ephemeris location, or do stellar occultation to figure out exactly our ephemeris data from that. So that's going to play a huge role in driving our processor sizing later on once we get to the component system design part of this project. CDH number 2 and CDH number 3 are related to CDH 1 in that they are our support of the nav payload. So the CNDH system shall receive nav payload clock data, and the CNDH system shall create nav data packets for distribution to nav users. The CNDH system will be supporting the nav payload processing of data, as opposed to with the COM payload, which will have its own processing system. CDH4 and CDH5 are also a pair. The CNDH system shall control satellite systems, and the CNDH system shall monitor satellite systems. Inherent to command and data handling is the control of satellite systems, and to close that loop with our satellite systems to make sure that they are doing as expected, we will be monitoring those systems to make sure that they are working properly. And we'll get into fault detection in a moment, but this will also play a role in fault detection requirements later on. CDH number 6, the CNDH system shall be able to process commands sent from Earth ground stations. So it's incredibly important that we have a way for our Earth segment to communicate commands to our spacecraft. Although, as I'll mention in a moment, that these spacecraft are autonomous, it's important we have a backdoor in. So, for example, our satellite enters a safe mode, and the satellite is unable to figure out what's going on. We need to be able to have a backdoor in so that way humans on Earth are able to debug our system, figure out what's going on, and get it back operational. As mentioned earlier, CDH7 and CNDH8. CNDH system shall nominally operate autonomously, and the CNDH system shall autonomously detect faults respectively. So we have 32 satellites in this constellation. That is a whole lot of satellites to be managed by Earth ground stations, and at many points those satellites will be out of view of Earth. So it's imperative that these satellites are able to conduct normal operations on their own and are able to detect faults on their own and, if need be, enter a safe mode. CNDH9 and CNDH10 are also a pair. The CNDH system shall interface with satellite systems with a to-be-determined digital data bus, and the CNDH system shall interface with satellite systems with to-be-determined number of analog ports. This is very much a component-level driven requirement, so we will need to figure out when we start selecting components exactly the data bus that they are able to communicate on, and that will drive what processor or onboard computer we select to make sure that it can handle that specific data bus. Here we have a preliminary hardware interfaces and data flow diagram. This is specific to our CNDH team, so a lot of these other systems are a bit more black boxes. There's a whole lot going on here, so I want to point out some basic things. In the middle, we have our CNDH system, we have an onboard computer, and we have a fault detection system that is currently discrete from our onboard computer. It's still to be determined exactly what that fault detection system is, but we want to keep it discrete at the moment, so that way it's well recognized within our system. We also have our tracking, telemetry, and command data storage. So if commands are sent up or a software patch is sent up, that will be stored here before being booted onto the onboard computer. As you can also see, the CNDH system interfaces with every single other system on the satellite, not only the comms payload and the nav payload, but also the thermal, power, propulsion system, GNC, and ADCS systems. You'll notice that commands are being sent to all the systems, so it could be like turn on or fire our hull thruster at a certain power. And data is being sent to and from the systems, so process data could be sent to our nav payload, like our ephemeris data, and that could come from our star tracker right here. So data will come from the star tracker, we'll go to our onboard computer for processing, and then that ephemeris data will be sent to our nav payload, which will then be sent through our payload antennas to the lunar user. Health data is also coming from all these systems. So for example, Hall Thruster will be sending health data to make sure that it is operating properly, and if something is not operating properly, we will be able to detect that fault and enter a safe mode if need be, or take other precautions.
Question?
Yes?
Where's the rest of the TNC subsystem on this?
That's a good question.
The receiver, transmitter, decoders, all that kind of stuff.
Yeah. So for the TT, the question is, where is all the other stuff that's required for our tracking, telemetry, and communications processing before, being sent from the onboard computer to the antennas? That is not really included on this diagram. We sort of put it on a big RF bus right here, but we will be adding the appropriate systems for that. Thanks.
Question?
Yes.
Ooh, sorry. So it seems like your navigation payload is very sensitive to latencies. Say, you get what time it is, and then you have to process that time, or you get a snapshot of where you think you are, then you've traveled 1 kilometer over 1 second, or more than 1 kilometer.
Yes.
Do you have any latency requirements for your internal communication and data handling?
At this moment, we do not, but we will be addressing those. Thank you.
Are all of your systems with your data system digital? As in, it implied there's no analog of any sort?
Um,
It did.
yeah,
again.
yeah.
Never
So
mind.
we have
Withdrawn.
requirements for analog ports.
Withdrawn.
Okay, cool. All right, and with that, I would like to pass it off to Lexi.